Okay, so I'm here with Svetlana Jitomirskaya, and first of all, congratulations for your Barry Prize.
Thank you.
I mean, I must say, this is a new prize, and you are among you are in the first cohort of the prize, which I am pretty sure is going to become an important prize, which will celebrate not only excellence, personal scientific excellence, but also some kind of commitment to both academic freedom and academic excellence. And of course, in your case, these are both true. So, so let's start by discussing somehow a little bit how you became a mathematician, in particular, what has attracted you to mathematics, especially given that you were in Soviet Union at the time.
And yes, it's a kind of a strange story because growing up, I did not plan to become a mathematician. I was very interested in literature, Russian poetry specifically, and that was my plan up until the end of high school. But when it actually came to starting to think seriously about where I go to university and all, I realized that pursuing my passion in humanities was basically impossible without constantly bowing to the state ideology, without praising the Communist Party in every sentence, and I wouldn't have been able to actually study the poets I loved without doing some stuff that I didn't like. So I basically realized that this is not something I wanted to actually do in that reality. And I was considering for a while to go to a small college in Estonia, where a famous linguist Lotman worked, and to study with him because this would avoid all these problems. It was one of the few possibilities in the Soviet Union to do that. But he was also known as a dissident, and that's why he was working in a small college in Estonia. And my parents got really scared of it, and they talked me out of it. They were very much against the regime, but in a very quiet way, and they really were scared of a dissident life for me. So
They didn't want to risk your life.
yes, they convinced me that I should not do that. And then math was kind of second best for me. So,
Okay. All right. So obviously you were good in math, so you could do one of the two things. And you found that math gave you more freedom.
yes, so basically math was least ideologically engaged, clearly, and still I kind of I was very self-conscious about the fact that I was kind of choosing the second best and not what I thought was my true passion. But after I really started learning math at the university, and only after that I developed a passion for math. And I remember thinking the sophomore year that I couldn't imagine actually myself studying anything else. So, but this came late to me, and it was not from the childhood.
Okay. But I know that I don't know, of course you are much younger than me, but there were lots of problems to study mathematics also. It was not easy for Jews in particular.
Oh, yes. So, okay. There was an easy path for me to study mathematics in my hometown's university, where they accepted Jewish applicants. But in the best universities in the country, which were in Moscow and St. Petersburg, they wouldn't. And so that was indeed a big obstacle. And actually, the fact that I was admitted to Moscow State University is kind of a miracle that I still cannot fully explain myself, because the truth is that what happened there, even though the whole rhetoric of the society was internationalism and friendship between all the nations, but in reality, things were different for some nations, specifically for Jews. And one probably explanation given for this by the authority, although it was never an official explanation, it was just a rumored explanation, was that there should not be more Jews at such places than their proportional representation in the country, which was like 1% or something. So in entering class of mass majors, people were admitted to a major. And at Moscow State University, there were like 500 mass majors admitted. There was many would drop out after the first year, so later the class shrank to 300 students in future years, but admitted were 500 students, and of those there would be like 2 or 3 Jewish students. And Jewish meant, so nobody, religion of any kind was outlawed in the Soviet Union, basically. Jewish meant ethnically, so everyone had a line in the passport, in their passport received at age 16 that indicated their nationality. But they also look on the lookout, like in the fascist Germany, for hidden Jews, those who had their nationality written as Russian or Ukrainian. Ukrainian was considered good at that time, but actually had a Jewish parent or even grandparent, because every person would get this passport at 16 and could choose between the nationality of their father and mother to put in their passport. So, and I was one of those hidden Jews. I was Ukrainian in my passport, but basically ethnically Jewish. So, and I didn't have much hope that I would get admitted because they were really on the lookout for people like me. But I was by basically some miracle. So my file literally was lost between my first exam and my second exam. So I know that in my first exam, they clearly, it was a written exam in mathematics, that they simply graded differently for Jews and not Jews. And I know that my exam was graded in a Jewish way, as I saw it was graded. But, and so I got a C. But then when I came to my second exam, which was an oral exam in mathematics, so people came there and everybody was taken to their rooms. And I knew very well that there would be a room for Jews where they would be subject to much more difficult questions. And I was preparing for that, but I don't think I would have passed that. But what happened is that my file, which was a paper file, was lost. For 40 minutes, they couldn't find it. They took everyone else to their rooms and they couldn't find my files. And then after 40 minutes, they found it and took me to a room. And I was not subject to these Jewish questions. It was a normal exam. Moreover, my examiners, they looked at my written exam and say, what is that? How could they give you a C? You should appeal. and I knew so they had no clue that things like that were going on. The people were examining me. So, so a true miracle has happened that allowed me to study at Moscow State University at that time. Yeah, but in principle, one could have gotten a good education a good mass education at a number of other universities in the country, and many people did. But really, the best opportunities, the best kind of exposure to top mathematicians was at the places where Jews were essentially not allowed, and I just got lucky. by some accident, and I realized how lucky I got. It was so unexplainable that I kind of felt it was important for me to pay back for this luck, to kind of really take all the opportunities that the university was offering to study for all these Jewish applicants that were not admitted. And that's what I did, and that's how I fell in love with math.
So you obviously got a great education at Moscow State. And when did you leave Russia, Soviet Union?
In 91.
In 91. So this was exactly at that time when...
I left straight after getting a PhD in 91. So PhD was also in Moscow State with the same advisor, which was kind of typical. I should say that also when I started working with my advisor, Yakov Sinai, it was, again, it was typical at the time. I started at the beginning of my junior year of undergraduate. And there were a total of 5 years of undergraduate. So it was 3 years of undergraduate plus later graduate school. So, and when I started with him, he said, you shouldn't even dream of going to graduate school. And the reason was not because I was a woman. He was actually quite very encouraging to me originally, but because he knew I was Jewish. I was a hidden Jew. And he said that they would never let you in. Right. And then I got lucky again, because by the time, this was still the bad times, middle 80s. And by the time I finished my undergraduate, it was perestroika and things have changed.
91, yes, right. So it was already...
I was admitted to graduate school with no incident, while just a few years before it would have been out of question.
I see. Okay. So you, in 91, you came with your PhD in the United States.
91, I got the PhD and came to the United States.
Was it difficult to find a job in the United States coming from Soviet Union?
Yes, my path was a little strange, because basically in 91, what happened was my husband was, he's a chemist, he was offered a postdoc, and I just decided I would follow him, a job or not. And so I just contacted a person, Abel Klein, a mathematician at UC Irvine, who I met in Moscow, who visited my advisor. And he managed to get some part-time lecturer position for me at UC Irvine, and that was my first job. And I was not really, I was not really planning to actually stay in academia at that time. Somehow I had some serious self-esteem issues. But then it so happened that I stayed in Irvine for 32 years.
You claimed that there were a series of lucky incidents.
There was a series of lucky incidents, yes. But so the thing is that somehow at that time, I think it was so we were not really planning to leave the Soviet Union. We did not. We actually had return tickets. So we were planning to just go to the United States for a short. It was not the Soviet Union anymore, and that was the motivation. So at that time, actually, there was a lot of excitement in Russia about it becoming a free country. So it was clearly a third world country, a country with, which basically didn't pay to do research. It was impossible to just be in research there, but there was a lot of hope for the future, and we were hoping that after a few years in the United States, that was our kind of initial plan, that we will come back to reasonable jobs there or whatnot, but somehow this hopes has been slowly dashed forever.
Right, so you stayed in the United States, which was good for this country, for United States. And can you say a few words about what are your mathematical research interests?
Yeah, so
obviously not nothing technical, just
right. So I work, basically, I'm a mathematical physicist, which means I work on problems that are at least motivated by physics and are of potential interest to physicists. And that is actually very, very exciting, especially on those occasions. And I was very lucky to have a couple when you actually can say something new to the physicists or prove them wrong. But basically, I am a mathematician, I prove theorems, and this is an area of pure mathematics. And some of my results, even though it's called mathematical physics, are not really related to anything practical. They concern some phenomena that happen at time frames that are longer than the lifetime of the universe, even if it is increased by a factor of 2, as we have recently heard. But still, the fact that these phenomena exist, they actually, one can say that they point to some better understanding of more practically relevant phenomena, but basically much of the stuff I do is simply mathematics. And mathematically speaking, the area is between many fields, uses tools from many fields: functional analysis, ergodic theory, harmonic analysis, probability, number theory, even algebraic geometry a bit. So it is very exciting, and there is a lot of very interesting things going on right now. It's very rapidly developing. So the field where I made most of my contributions is so-called quasi-periodic operators. So these are some objects that quasi-periodic Schrödinger operators, more specifically objects that come from quantum mechanics, but related to structures that look periodic at small scales, but then but are actually not periodic and look a bit chaotic at some other scales. So this leads to various phenomena, and they become very, very amenable to rigorous analysis in some sense, which leads to some very satisfactory results, which can describe systems for all levels, for all values of parameters and stuff like that.
Okay, very good. So now let's talk a little bit about your adopted country. Now that you are a mathematician in an adopted country, how do you view the strengths of or weaknesses of how mathematics is being taught and practiced at the research level in the United States?
So I love America very much, and I think so. Actually, I think of myself as American now, and I think it's a country of tremendous opportunities and tremendous will and strength for innovation. And I think in particular in education, it's now a great time when I'm very hopeful that the United States will embrace all the innovations that comes from the AI. So I see things like in the possibilities for online education. For example, things like this Khan's Academy and this there Canmigo, and I'm sure there will be similar engines which basically can provide high quality one-on-one tutoring to all. And I think these are the definite advantages, the fact that such things are actually centered in the United States, happening in the United States. The disadvantages are, of course, various political forces that prevent this happening at scale, and basically the fact that much of the, so I don't know if it is good or bad, but basically various education decisions are made locally at the school district levels, and as a result, in some school districts it's good or better, in some school districts it's horrible, in some states it's better, in some states it's horrible, and it's all a function of time. In the same state it can go from good to bad. And the various political forces that prevent good things from coming. And of course, the really bad thing is a bad preparation of many teachers. And I see the good thing that I mentioned, the fact that there are now these possibilities to have this basically very high quality individual online tutors, coupled with the fact, with the realizations that bad mass preparation of many teachers is a bottleneck for high quality education, should lead, hopefully the society should realize, and this should lead to some good solutions, maybe even in the near future.
But of course, so what you are describing with AI and other
Right.
incredible new possibilities, it's more sort of education at an individual level, like
Yeah.
homeschooling, which is becoming very big.
No, but what I see coming, actually, what I hope. So okay, so there were some very bad developments recently, for example, with this California mass framework, which kind of attempted to basically dump down the education for the entire state, and it's the state of California, no less, which is a bellwether for what happens in much of the rest of the country. But I think it's being successfully fought back as we speak, because, for example, just this month, the University of California managed to, the committee made of professors from each of the UC campuses basically unanimously rejected a possibility for some of these basically non-mass-based data science courses that were promoted by this California mass framework to validate for Algebra 2 in the UC admissions. It reinforced the role of algebra, of strong mathematics preparation for all admissions, not only in this counts, not only for the UC system, but also for Cal State system, which is actually more relevant there. And I think, and this was just recently, just on Wednesday, on March 20th, essentially approved the meeting by the regents of the UC system. So basically, I think things are going back to sanity, and I see it as, I'm very optimistic that that basically people start to understand the merits of good education and actually of accessibility of good education to all who are willing to get it. Another recent development in California, the city of San Francisco in the recent election, 82% voted to reinstate reinstate Algebra 1 in 8th grade for students in the city, something that was basically outlawed in the city for some 10 years, and people got fed up. And I am really amazed by this 82% vote, and it makes me very hopeful.
Oh, okay, that's I didn't know about this. That's very interesting. But obviously, in all these things, you are dealing with a lot of bureaucracy, and of course, this bureaucracy we see a lot in universities.
Oh yeah.
Major universities. So, how worried are you about recent?
Yeah, this is definitely a very bad trend. I saw some graphics showing how bureaucracy in the universities have grown in the last several decades by several factors, by several times, while the number of faculty stayed about the same. And clearly this is not good. And in a sense, again, the innovations, the AI and all should actually help reduce the bureaucracy. And I'm hoping that this process will soon start. I am actually, I don't know, maybe I'm too naive and too stupid, but I'm an optimistic person. I am actually very hopeful that this was kind of a period, growing pains in some sense, that will come to an end, and that things will go back to how they should be, with bureaucracy playing a much more minor role.
But I do believe that you're right to be optimistic, but it's not just optimism is not enough. It's important to have people like yourself who have fought against this, the sort of the bad things that have happened.
Yes, it's important to find against the bad things, even minor bad things, because otherwise they tend to grow into more serious bad things, and to fight against whatever you can. And those bad periods can last for many years, and it may be your lifetime. You don't want that, right? So I want all these good things that I am optimistic about to happen in my lifetime. So.
That's great. That's wonderful, Svetlana. Thanks a lot. I mean, I think this was it was wonderful to hear your voice, and congratulations again for the Barry Prize. And
Thank you very much, Sergiu.
I'm sure that we will hear more about you in the future. So,
thank you. Okay.